Alright, draft science video. So I think I'll talk a little bit more about the two subjects between Hathliday and Piro. And so let's do the gravitational lensing first. That's also a Piro subject. But I think this is a closed subject. In a sense, I win. You know, obviously physics has left its best work somewhere else at home. And they've really missed an awful lot of logic here. Instead of contriving things like dark matter, they should have been actually thinking about how light is going to get bent around a sun or a gravitational body. So I'll just draw it one more time just to point out the argument. Now the argument is, here's a gravitational body. The gravity at these different locations gets weaker and weaker and weaker. Now the idea is there's something really far away over here, and what it's doing is it's sending light out, little photons, and they're diverging. And the idea of the lens is to converge those diverging radians. So the idea is you want the lens to be able to reverse the spread between these photons. That's what a traditional lens does. Now the simple truth is, a gravity lens is configured exactly the opposite of what you need. So if you imagine the photon going very close to the surface will get diffracted or bent, it'll curve the most, and that means its angle is going to be sharp. And as this goes out, the divergence is going to get like this. But the end effect is, and this is the important part, the divergence here is going to be made worse. The light's going to be spread apart even further. It will never converge. And so the best the gravitational lens could ever do is, if you think about facing it like a globe, the best it can do is it can pick up a photon from a single location. So here's the gravity that bends the light the right distance each time. This is the right distance from the object. So you could think of the Einstein ring. Now the Einstein ring, though, can only work as an incredibly thin ring. So thin that we probably wouldn't be able to see the light. It couldn't have any depth. And we know that all the gravitational lensing images are thick smears. Very thick. Many light years across thick. And that gravity would be getting weaker and weaker. So that could never happen. It could never create a thick Einstein's ring. It would only be the thinnest of lines, because everything a little bit further out will never get to us, never get bent enough, and anything closer is getting bent too much. So I don't know exactly how to draw that, but basically the light that's a little short will go this way, the light that's a little too far out will go that way, and you'll never be able to converge it. And so you're only going to get the one beam from this edge, and that's it. So that's the only possible gravitational lens the cosmos can create. That's it. I made the argument that maybe you could take two planets and put them next to each other, and because then you'd have stronger gravity on the outside and weaker gravity in the center. But the problem with that is obviously the lenses are going the wrong way, so you got the same divergence problem. All the light's just going to diverge. So you have no hope. So I'm just saying, I don't think Hathliday can defeat this argument. The entire gravitational lens thing was poorly thought out from the beginning. It couldn't have been done. Every one of these people claiming it's a proven fact have been duped and are fools. And yeah, it was a stupid idea from the beginning, because a photon doesn't have three dimensions. It can't be moved. It can't have momentum in two directions. It can't both go this way, the speed of light, and then some other way. It can't do both. It's not matter. Matter has three dimensions. It can do three different velocities at the same time. I can be going a little bit this way, and a little bit that way, and a little bit this way, a little bit that way, and a little bit that way, all at the same time. A photon can't do that. It's wrong-headed from the beginning. The whole thing is, it's done. It's cooked. Show me how this is wrong. Show me how further out you go from the planet, the more the photon gets bent. Show me how any logic, any Einstein equation, anything in the universe makes that make sense. No, it bends less. The further from the sun, the less it gets bent. You need exactly the opposite to create a lens. So, subject annihilated. A big ton of physics annihilated. Again, I'm going to annihilate the standard model. Electrons spinning around, annihilated. It's all going away. Quarks, bullshit, gluons, shit-ons, fuck-ons, they're all going away. It's all bullshit. Alright, anyway. So I was thinking about the time dilation thing, and I was just thinking of different ways of being able to measure absolute velocity. And so, obviously this light thing would work. If the experiment is perpendicular and you shoot light across, you'd be able to detect your speed based on how much you miss this dot. So this dot is going to be moving your speed, which is going to be subtracting from the straightness of the light. The light can't get to it because you're moving it away before the light got there. So whatever speed you're going relative to the speed of light, this target will move away before the light gets there, and the light's going to end up hitting some spot behind it. Now the problem is, right, slow velocities like we're dealing with thousands of miles an hour are going to be impossible to detect with a light like that. You have to use mirrors, and then you'd have to know ahead of time how to angle the mirrors, and that would get a little messy. But I still think they could do it with that 4-mile long interferometer. But I was thinking of another way to do it. I mean, first let's call it magnetism, which you need. The point is you need to send a force. You need to send something that moving in the speed of light, because all the things moving the speed of light never carry the momentum of the emitter. The emitter can't change their speed. It can only change frequency. It can't change speed, and it can't change direction. So think about a light bulb on a car. If I put a light bulb on a car and I move the car 200 miles an hour, you know you're not going to get much light from the light bulb. You're barely going to see the light bulb. It's going to seem so dim because it's moving and the photons keep missing you. You only get a tiny number of photons. So I was thinking about that, and I was thinking, so the idea is the Earth is rotating, spinning, and so I was thinking of using radio waves. Now radio waves are kind of fucked up because what they do, here's the land, let's say it was a flat Earth, they're basically bouncing off the atmosphere and bouncing down, so they cheat. They don't move in a straight line, and that's how they get from one side of the planet to the other side, as they bounce off the atmosphere. But the point is even though they're bouncing, there's still probably going to be a point where they're strongest and they're weakest. They're still going to have a radius of intensity. So I was thinking, if you put a radio tower somewhere in Canada and you use GPS to get the exact longitude line perfect, and maybe put something around the equator, and then use the very good low band radio wave. But see, that's the thing, is then the wavelength is getting so long that it's going to spread too much. So you have to try to use like a microwave or something like that. It might be a work, I'm not sure. Microwaves might be too straight line, so you need something. Well, anyway, the shortest wavelength radio wave that will still bounce off the atmosphere. Okay. And then at the other end you put a bunch of radio towers. Okay, so you're sending the signal out from one place in these clumps, these frequency clumps, obviously. And the point is the straight line will be the most intense. Okay, so as the Earth is rotating, so you're sending the signal, its signal is going to be moving, the Earth's going to rotate this antennas out of the way. So the point would be is to have, say, 20 antennas here on the equator, separated maybe by 10 feet. And then just measure on those antennas where the strongest signal is. And when the Earth is going this way, okay, the signal should be biased in one direction, and when it's going the backside at night, going the opposite direction, the bias should be the opposite way. So I think it's doable to find our absolute velocity, at least in a couple of directions. Yeah. So anyway, that's it for the video, I think. So I want the Piro explanation of if he thinks his time dilation will make it possible for him to see the light actually go straight across, because it won't, and he'll know how fast he's going because the light will hit different. The light clock can't fail. If you're going half the speed of light, the light clock can't fail. Say if this was 4 feet across, even, it should be something like, your spaceship should be better than 4 feet, but just 4 feet would be enough, because for every 2 feet you went here with the light, you would have moved the target 1 foot, and there's no way the first photon would ever hit this. It would be 2 feet gone before this moved the 4 feet. And so you'd hit the wall 2 feet away from where you think the light should hit. So the light clock won't fail and telling you you're the one with the velocity. And the radio clock won't fail in terms of telling you whether the Earth is moving this way or the Earth is moving that way, spinning on its axis, which way you're going. Technically, it'll tell you, and then when you're going in the sideways direction, it'll tell you how much sideways motion you have. So it'll tell you 2 motions. It'll tell you how fast you're going this way, and it'll tell you how much you're going this way. And the only one that'll be missing is the intensity going this way, up and in and out. So you'll be able to detect 2 of the dimensions probably with that one experiment, I think. I didn't think that through, so that's just a draft comment. But there's nothing draft about the failure of the idea of a gravitational lens, and somebody should have figured this out a long time ago, that it's completely inverted. The lens is completely incapable of doing what it has to do, which is converge diverging light. It can't converge the diverging light. It can't create a focus. Therefore, it can only do a tiny, like I said, I don't even want to tell you how thin a line this Einstein ring should be. It's just a preposterously thin line of light. It's all you could possibly hope for. And it would be so thin that you'd never see it. So there's no theoretical. Gravitational lensing is theoretically not possible. There's no physics to defend it. Argue me wrong. Show me how farther away from the sun the light bends more. Show me how a photon heading further away from the sun gets bent more. Can't do that. Impossible. You're done.